Hello, everyone. Welcome to our webinar on improving charcoal stoves for better energy efficiency and climate impact. I'm Sylvia Herzog from the Charcoal Project and happy to have you here with us today. Before I dive into the agenda, just a few housekeeping items. Please keep your microphone and your camera off so that we can ensure good connectivity for everyone, unless you're one of the speakers. There will be a Q&A session at the end, so we encourage you all to put your questions in the chat function, and then we'll address them all together at the end so we can get everyone to discuss it. But feel free to answer any other questions that are in the chat, because that promotes a lively discussion. After our presentation, we'll be consolidating the slides and the recording, and we'll send it all out to everyone. So we'll mute people if we hear them pop in unmuted, just so you know. So to go over our agenda today, I just wanted to tell you a little bit about what we're going to do. First, I'll just give this brief introduction, introduce everyone, and then we'll dive into our presenters. Our first presenter is Dr. Priya Karve, who's the Managing Director of Samuchit Enviro Tech based in Pune, India. Dr. Karve has a PhD in physics and is specialized in developing technologies that convert waste to energy and promote cleaner cooking options. In 2005, she started Samuchit Enviro Tech, a social enterprise that promotes environmentally sustainable energy and lifestyle products. Today, Dr. Karve will present on why solid biomass fuels will continue to be relevant despite the availability of other options. And then, of course, why we still need efficient biomass stoves to go with that. Also to let you know that Dr. Karve is on the board of the Charcoal Project, so we're very happy to have her expertise. Once Dr. Karve is finished, we'll move on to Dr. Dan Sweeney, who's the lead researcher of the Biomass Fuels and Cook Stoves group at MIT D-Lab. The Charcoal Project has worked with MIT D-Lab for a long time on our Harvest Fuel initiative, and Dan has been integral to that effort. He's going to talk today about designing efficient and clean burning charcoal stoves and MIT's efforts in that area, as well as some of his field research. After Dan, we will move over to what's going on in the real world. Rehema Nakyazze, the CEO of UGASTOVES, will tell us about her efforts to bring improved charcoal stoves to the Ugandan market, both the opportunities and the challenges. And she's operating in Uganda, primarily in Kampala. So that'll be really interesting to hear her take on that. Before we dive into those speakers, I just wanted to talk a little bit just tell you briefly who the Charcoal Project is if you don't know. A lot of you have been on these webinars, so you've heard this before. But we're a nonprofit based in the US that promotes better fuels and technologies for people who depend on biomass fuel for their everyday needs. And we do that by supporting our clean energy entrepreneurs through our Harvest Fuel initiative. We also provide online resources to stakeholders in the sector. And we advocate for sustainable practices for wood fuel and charcoal consumption and production. And these webinars are part of that last effort to advocate for sustainable practices. So we've been producing these webinars through much of COVID, and with the hopes of talking about issues that are relevant for most of you. You know, the big issue about why are we focusing so much on charcoal, which, you know, we get that question a lot, is that it's a huge fuel. It's hugely needed and used throughout Africa. If you see from this map, these are all the countries where charcoal is produced. And it's pretty ubiquitous throughout Africa, and particularly sub-Saharan Africa. It's not only an important fuel source, but also really important for the economy. It's a source of livelihoods for many rural producers, and it produces income throughout the supply chain for many people in these countries. So it's definitely a huge piece of a lot of these countries' economy, and not really going away soon, which is why we're talking a lot about it today. To give you a sense of the size of the market, this is how much charcoal was produced worldwide, and then also in Africa. you can see, despite our efforts to move to more modern fuels, that the charcoal market is bigger and bigger every year, and has grown quite a bit since the year 2000, both worldwide and in Africa. And Africa has a lot of that growth over those years. And a lot of this is due to increasing population as well as increasing urbanization, because it's easier to use charcoal in the cities than wood to find wood fuel. And then there's another slice at that, literally, just to show that Africa is getting an increasingly large slice of a bigger pie every year. So they're becoming, Africa's becoming more reliant on charcoal, not less reliant. So it's something that needs to be addressed, and we can't sweep it under the rug like many people would like to, and focus on things like solar. We do have to address this charcoal issue. So with that, I am going to turn this over to our first speaker, who is, as I introduced, Dr. Priya Karve. Priya, I'm going to stop sharing and let you share your screen.
Thanks, Sylvia. Let me share my screen. Okay, thanks. And it's a pleasure to be here and talk on this really very important topic, which gets ignored mostly in the energy discourses. So I'm going to sort of broadly talk about why we still need efficient biomass stoves going ahead. And then the speakers after me will, I guess, dive into the specifically charcoal stoves topic. So these are two statements which are mentioned often whenever there is a discussion or discourse on biomass based cooking, that nearly 2 billion people worldwide are still cooking on solid biomass fuels, and most of the time these are being burnt in smoky, inefficient cook stoves. We also have indications to show that in spite of the increasing access to what are called as modern cooking fuels, which is primarily liquid petroleum gas or natural gas or electricity, the absolute number of people that will continue to use solid biomass fuels for cooking, that number will increase by 2030. So even though the reach of modern cooking fuels is increasing, the number of people cooking on biomass fuels is increasing at a faster rate, apparently. So these are very much backed by references and studies, and you come across these statements often. Let's try to unpack this a bit and try to understand why this is happening, what are the issues, and why do I say that biomass fuels and cook stoves will continue to play a role in the future also. So if you think about traditional solid biomass fuels being burned in traditional cook stoves, which are the smoky cook stoves that everybody wants to get out of the kitchens. Um, there are two angles, two lenses from which one can look at this. One is the climate lens. What is the greenhouse gas emissions associated with this particular cooking approach? Now, this is a bit complicated and difficult to answer in black and white. There are a lot of gray shades there. As far as access to biomass fuels is concerned, the context is very much important. There are pockets where we can see that these fuels are being sustainably harvested, and one can even show that this is being done in a carbon neutral manner, particularly where people are using, let's say, agricultural waste. So if you don't use the waste for cooking, then either it will be just burnt off in open air, or it will decompose, and that carbon dioxide is anyway going to end up in the atmosphere. So might as well use it, extract an energy service from it, while the carbon dioxide is on the way to the atmosphere. That's the philosophy. However, because the stoves being used are not very efficient and are producing emissions, there are possibilities of other greenhouse gases like methane, black carbon, etc., being produced. And that is the climate change impact coming from these cook stoves. There is the health angle to it, which is fairly straightforward, that if you are using a smoky stove in the kitchen, the cook, which in most economies where traditional cook stoves and biomass fuels are being used, are typically women and their children who spend time close to the women. They are getting exposed to the household air pollution, and therefore they are suffering adverse health impacts. There is now sufficient data available to prove that linkage between exposure to household smoke and health impacts. So what are the solutions therefore that are being suggested? Now, these solutions are being suggested purely driven by the health agenda. And therefore, fuels that burn cleanly, which do not produce any pollutions, that is the natural sort of logical substitute that is being proposed. And that is LPG or piped natural gas, PNG or grid electricity. Now, from climate change perspective, there is no doubt that these fuels are contributing to greenhouse gas emissions because these are all based on fossil fuels at this point in time. Electricity also primarily is coming from burning mineral coal. However, health wise, generally these are considered to be clean fuels and therefore no adverse health impacts associated with them. And as I said, it's primarily WHO and the health agenda which is driving this whole process of wanting to replace traditional biomass fuels and cook stoves with these type of fuels and cook stoves. However, there are other things that are happening around this. One is climate politics. As the world is trying to shift away from fossil fuels, what is going to happen to these fuels? How reliable is going to be the supply? What kind of prices are we going to see? There is a lot of uncertainty around that. Natural gas seems to be thought of as the lesser of the evil fossil fuels, and therefore now people want to do everything with natural gas. We are even having a war going on over natural gas. But then that creates more demand for natural gas. So how much of that is going to continue to remain available for cooking where the price cannot escalate beyond a certain limit? LPG is a byproduct of petroleum refining. So as petroleum fuels start being phased out, what is going to happen to its supply? As electricity sector transitions away from coal, there are going to be a lot of disruptions. How is that going to impact availability of electricity in the developing world? So there are a whole lot of issues associated with the way climate politics and energy dynamics is playing out. And interestingly, some research has been emerging in recent times, which is indicating that use of LPG and PNG also may not be as clean as it was originally thought to be. So then what happens to the overall health argument in pushing these fuels? So that is becoming a bit of a question mark there. So this is basically the dilemma of the clean cooking sector right now, that on one hand, there is apparently a health-driven strategy to replace traditional biomass stoves with fossil fuels and grid power. The expectation here is that you just have to introduce these modern fuels and they will get taken up. There will be 100% fuel substitution, zero household air pollution, health problems solved. What is happening in reality is that the modern fuels, the access is not reliable, costs are fluctuating, and stove stacking is happening. Stove stacking means people are using these new stoves, but they continue to use the traditional stove also side by side, which means that household air pollution still persists. So the health agenda is not being met, and you are replacing a potentially carbon neutral fuel with a 100% confirmed greenhouse gas emitting fuel. So in trying to solve the health problem, even that is not getting solved. But on the other hand, you are contributing to climate change problem. That's the situation in which the sector has got stuck. Why is stove stacking happening? Why is it that people continue to use their traditional cook stoves even after getting something like an LPG stove or a natural gas stove or an electric cook stove? The main reason is that if you look at the rural context, the cook stove is not just used for cooking, it serves many other purposes. A rural household will not have a refrigerator. Instead, the food will be kept on a clay stove which is slowly radiating energy. The food is kept warm, which is also acts as a mechanism for preserving food. The same stove is going to be used for water heating. There is no separate water heater. In cold climates, for space heating also, the heat radiating out of a clay stove is serving that purpose. Next day's fuel wood can be dried out by putting it around the cook stove. The smoke is being used for insect control. There are also a lot of cultural and religious functions associated with a traditional stove. When you replace this stove with something like an LPG stove, which is designed purely for cooking, you are getting a very clean and efficient cook stove, but then all these other functions, how are they going to be met? So people will continue to use traditional cook stoves to meet these other functionalities. So that's that. There is also another aspect to it, which is that the process, the efficiency of a cook stove is measured in terms of how well it is designed to boil water. So essentially, these stoves are best suited for boiling, not necessarily for other cooking operations. So that will also play a role in cultural cooking context. There are other issues. Traditional stoves would either be self-made and therefore zero cost or low cost. If the manufacturer is local, service and spare part support is more reliably available. Fuel cost, at least from the perception of the user, is zero. Clean cook stoves, the modern fuels, these are expensive stoves, no local service and spare part support. Fuel needs to be purchased, and therefore there is an ongoing expense and also a risk of the supply chains getting disrupted. So because of all of this, the 100% immediate transition to modern fuels is just not happening. And that's the reason why the health agenda is not being met. An intermediate solution, therefore, can be what are called as cleaner cook stoves. Now, what are cleaner cook stoves? These will continue to use the biomass fuels, solid biomass fuels, which people are already using. So the fuel supply chains are already in place. But the stove design is such that it reduces, if not eliminate, it at least reduces harmful emissions from the stove. So it in a way serves the health agenda, and it also takes the whole use of fuel and stove combination towards carbon neutrality. Because in the poorest household, if a traditional stove gets replaced by a slightly improved cleaner cook stove, then the household air pollution is at least reduced, if not eliminated. In a stove stack, if people are using, let's say, LPG or PNG stove, electric stove, and a traditional cook stove, if the traditional cook stove in the stack gets replaced by a cleaner cook stove, again, the overall household air pollution is going to be reduced. And because these stoves are more efficient, the fuel requirement is lower. And that is why locally the process can move more strongly towards fuel sustainability as well as carbon neutrality. So in a way, this can be a way forward, this can be a win-win situation. There is also something else that I would like to raise here in the context of this overall health agenda. And these are the questions that everybody, I think, you can answer them in your context, especially in tropical countries. What is the baseline outdoor air pollution? Because the outdoor air in any case is polluted in many locations, and there are various other sources which are contributing to that. This is particularly significant in tropical locations because the kitchens are not insulated. There is an air exchange happening between the house and the outside air. So it's important to see what is the baseline air pollution, even if no stove is being lighted. That air in itself is not very clean. There is a lot of air pollution there. And under those circumstances, therefore, we can't really, I mean, the way this is being projected is that you replace the traditional stove with a cleanest possible stove and miraculously all the women are going to be healthy. That is a ridiculous expectation, because air pollution has many other contributors. The cook stove is just one of those. And therefore, if the objective is really to have a health focused air quality improvement, just the cook stove cannot be a vehicle for that. There has to be a multi-pronged approach, which I don't see happening. So I really question the motivation behind putting health as the driver for pushing this transition. um, I feel that we have to think differently. Firstly, from a long-term perspective, if the world has to move towards a fossil fuel-free future, then even in the kitchens we cannot continue to rely on fossil fuels. That means energy transition needs to happen in urban kitchens also. In the developing world, the urban kitchens today have converted to LPG, PNG, and electricity, but they also have to move towards renewable energy. In rural areas, you already have a potential renewable energy set up. How do we enhance that? How do we remove the ill health associated with that? That has to be the thinking there. And then there is the whole sector of commercial cooking or large scale cooking or community cooking. There also some innovative thinking is possible. So this is sort of a vision of a net zero kitchen across rural, urban, and large scale cooking. In rural context, biomass fuels will continue to play a role, but these could be processed biomass fuels, and charcoal is one of those. It could be charcoal, it could be biomass briquettes or pellets. These are processed fuels, and therefore one can design stoves for standardized fuels and really go down to really bring the emissions very, very down, even very close to the so-called modern clean cook stoves. So that is the approach we have to take. There are other possibilities like biogas, for example, which is not a solid fuel, but it is still a biomass fuel. Solar cooking can support this in some locations. There is still a lot of work that needs to happen for developing low cost, low tech innovations in fuel production along these lines, and also cook stove technologies. In urban setting, how do we move away from LPG, PNG, and coal-based electricity? This can be, again, processed biomass fuels from own and neighborhood organic waste. So this will provide a solution to urban organic waste management, and also in the rural context, it will work in that way. So again, here also, we ourselves are introducing um, charcoal briquettes made from garden waste in urban setting, and biogas made from kitchen waste. So this combination works fairly well. Solar cooking, thermal, as well as PV with battery backup definitely can go with that. In urban area, you don't have price constraints. You can go for high-tech solutions. LPG, PNG, electricity, which is already available, can sort of take a back seat. But again, here what we are seeing is that the problem is not so much of cooking technologies. The limitation is architectural, how the kitchen is designed and built. So there needs to be an innovation to overcome the space and time constraints which urban kitchens are facing. In the case of commercial cooking, actually this can be a very, very good approach, and many big institutional kitchens are taking this path already. Solar powered steam based cooking, add to it biogas from own kitchen waste, and use LPG and electricity as a backup. Because these kind of large scale kitchens have to pay a commercial price for fuels like LPG or electricity, for them the economic incentive is very, very attractive to take this path of renewable powered kitchens. But again, how do you hybridize these multiple technologies to create a smooth, user friendly, efficient process in the kitchen? Work needs to happen there. So there are sort of out of the box approaches, but we still need R&D investment to go into this to improve these processes and make them more and more realistic. These are just some of the examples of technologies that we ourselves are promoting in India. Wood burning or biomass fuel burning cook stoves with chimneys, or portable ones, metallic with insulating bricks inside. What you see down here, this is a steam cooker which works on charcoal briquettes. So in 100 grams of char briquettes, you can steam rice and some curry and something else. So 3 items at a time. The second stove on the bottom here, this is a stove which is using woody biomass waste. The wood gas is being used for cooking, and it will leave behind charcoal which can be used in another charcoal stove. This is a charring kiln that we have designed mainly for urban applications, which is a small one, portable. You can put it in your garden, convert your own garden waste into your cooking fuel. So there are processes like that which are being taken up. And we also promote solar cooking and food waste-based biogas as sort of support for these systems, so that one can collectively, using these technologies, create a practically usable, clean and green kitchen, which will serve both the health and climate agenda. So basically, I mean, if you look at this photograph, this is one way of depicting stove stacking. This is a family which has been given an LPG stove connection, but they cannot afford to buy a refill cylinder, so they are creatively using the cylinder in a different way. So this is also an example of out of the box thinking. We essentially need out of the box thinking, which is user centric as well as culture and economy sensitive, to address these complex issues in the cooking energy sector. One cannot think in a very black and white way that wood based or biomass based fuels cause pollution and therefore replace them with something clean. It's just not that simple. There are many more nuances to it, some of which I have tried to highlight in this short presentation. Please do visit the websites that I have put there. Samuchit.com is where you will get more information about the some of the stove ideas that I showed on the earlier slide. Cleaner Cooking Coalition is an international organization which is promoting this very idea that biomass based fuels using locally available biomass is actually, it can play a positive role in the future cooking energy system, which is climate aligned and serving the health agenda also. So I'll stop here. Thank you very much for giving me the opportunity to share this thinking here in this forum. Thanks. I'll stop sharing.
Great. Thanks so much, Priya. That was great. I love your insights, and I'm sure we'll have a lot to discuss in the Q&A session. So now we're going to turn it over to Dan Sweeney from MIT Lab. And Dan, as we said, is going to talk about some of his work on improving charcoal stoves. And Dan is starting to screen share. Great. Thanks, Dan. Turn it over to you now.
Okay, thanks. Here we go. Let's see here. Just make sure I can get the big one up. Great. Thank you so much, Sylvia, and thank you, Priya, for that very good introduction leading into my talk. I think that sets a really good stage for this talk, and I'm going to focus a little bit more on the charcoal cook stoves. I have a little bit of experience working with those. I'm a researcher at MIT Lab, and I've worked a fair amount in the past with Sylvia. We've been involved in a couple of programs. I think she mentioned the Harvest Fuel Initiative, where we had the chance to work with small manufacturers fuels and also stoves. So a lot of this experience that I'm going to talk about here comes from over the past about 10 years and working with some of those small manufacturers. Most of what this talk involves is some manufacturers in Uganda that me and my students and other collaborators have worked with. I call it improving locally manufactured charcoal cook stoves with MIT D-Lab. So at D-Lab, in general, we are a lab. Our tagline is designing for a more equitable world. We work with community partners. We have a big network of community partners. I think a lot of you are actually on the call, so nice to see you. But we collaborate with community partners to work on technologies, not just cook stoves, but across a lot of different sectors. And in general, to try to improve technologies, to improve the lives of people living in poverty. Throughout our projects, we follow what we call the participatory design process. A lot of you are familiar with design and engineering. You've probably seen something like this. I just wanted to quickly introduce it because it leads into a couple of the projects that I'll talk about. So in general, our design process involves kind of 3 general steps, and we actually present it rather than just a regular simple circular cycle. It's more like a spiral. Early on when developing a product, we teach our students, and we actually put in practice going out and gathering information, insights. And this oftentimes means, getting out into the villages, the communities, wherever we happen to be working, and talking to a lot of people, sometimes informally and other times in a more rigorous way through interviews and surveys, but really learning about what are the constraints and challenges, needs, preferences, those kind of things. The next step is a little bit more fun, I think, is more of the coming up with ideas and approaches toward the challenge or the solution. So ideating, brainstorming, building simple models and very quick, simple prototypes to present your ideas, get feedback really quickly, and try to narrow down on a few ideas. So we'll generally start out with a lot and then try to bring it down to a few. And then the last one, I do quite a lot of this, is the testing. So you have, say, 2 or 3 concepts you're excited about. Other people on the team have, given some good feedback on those. Let's go ahead and take those either into the lab or into the field and really get some measurements and results to either validate or invalidate that approach. So this picture, I don't know if Saeed's here, but this is Saeed from Kenkoko in Kenya. And we had a chance to test one of his, this was Nyamachoma. This was a stove for Mishkaki and Nyamachoma in Kampala at Creek. So we try to use lab methods. Some of what I'll present today is around lab testing, but also doing a lot of testing and evaluation in the field if possible. So a couple of the reasons that I got interested in charcoal stoves, aside from, working with charcoal manufacturers and briquette manufacturers who had started also making stoves. So one of the reasons was I just saw a lot of people using charcoal stoves. So I think Rehema is going to talk more about this in Uganda, but everywhere I was going, especially in East Africa, you just saw a lot of people using a small, either Jiko style or some other similar style of cook stove, like this one in the picture. I remember in the evenings going around in Kampala and you just see, glowing red from out on everybody's doorsteps or on the sides of the streets, emanating from all those charcoal stoves. And then I'm reading in the literature, kind of like what Priya mentioned, there's all these challenges with other stoves, other stoves being introduced or maybe given away. Adoption was coming up as a major problem. So we actually thought about, how does that compare with some of the locally made charcoal stoves that we see people using? So in a few studies, people actually instrumented cook stoves and tried to understand how people's usage changes over time. And there's a few kind of famous studies that actually show people tend to drop off usage over time. And like Priya said, revert back to traditional or maybe mix, the improved and the traditional stoves. So we had this thought, let's why not try this out with some of the people we're working with in Uganda? So this is one manufacturer in Soroti that we've done quite a lot of work with here. That's the Maka stove. And so we actually just designed our own little package to monitor usage. And so it produces a signal kind of like this. And that tells us basically when the stove is in use. And so we left those little packages on the stove for quite a while. And we found that, yeah, people use these and they use them quite consistently and regularly. So we didn't do a huge project. Again, like most of the work that I do, we were kind of bootstrapping. So we sampled a few new users and existing users, and we studied them for, actually it ended up being about 6 months, but here's at least the first 4 months of data from that project. And we found, you know, kind of like what other studies showed, people go through a little bit of learning and adjustment when they get a new product. So the new users had a little bit different trajectories. Some were slower to ramp up with their usage. So a 1-to-1 45-degree line here represents 1 day passing and a day where the stove is used. So a flat line is kind of like when we get the flat line on our heart monitor, no usage, no response. But the existing users, you know, were, other than this one person, which that's fine, they pretty much used the stove daily, and in talking to people, they said, this is the one I want, the one I use, I can afford everything. The person's there, like Priya said, to provide after-sales service. So I thought, okay, these are interesting. And not that many people are really talking about this outside of you know, the communities themselves. Another thing that motivated me is that charcoal stoves, while there are some issues, we understand that. And definitely if you look at production of charcoal, especially unsustainably, there's a lot of, you know, urgent issues. And I think that's been talked about in other webinars here. But when you use them in a cook stove, and especially in an efficient cook stove, that's these triangle points, they actually are pretty clean. Other than some issues with carbon monoxide, which I think everybody would know about. If you don't, then, you know, if you are using a charcoal stove, it should be in a well-ventilated place. And we've been doing some work on improving carbon monoxide emissions, but especially the PM charcoal stoves, you know, most of the PM is emitted when you produce the charcoal. Volatiles are released at that time. So they actually perform quite well. So PM, you can see a lot of the stoves that we were looking at in this project in Haiti, we're in, you know, tier 3 or even higher, tier 4. This is in the ISO, the older ISO system. So the highest performance levels for PM were found by charcoal stoves, and the corresponding, you know, wood stoves were much, much worse. These were generally just 3-stone fires, kind of like you see in the picture here. So I was, again, you know, surprised. Here's these locally manufactured charcoal stoves that actually do quite well, other than that CO issue. And one of the things I've thought about recently, and has motivated me even more to continue working on charcoal stoves, is they have disseminated so effectively. So I think it was back in the 80s, Rehema probably knows better than I do, but in Kenya, they were introduced by, I think his name was Max Kinyanjui. I didn't meet him ever, but I've heard about him and met his children. And it sort of has spread across Africa and even into other places. So there's some great resources which I think help do that. And a lot of, you know, innovative, interesting small manufacturers, kind of like this one in Kampala, who've picked up those designs, adopted them, and put them into the markets as an affordable solution for households. So I was impressed by that. And I also thought about, is there a means that we could disseminate improvements through those same networks? So I'll get to that a little bit later. So the first project that we did around charcoal stoves was, again, in the community in Soroti, Uganda. And a master's student of mine, Lauren Bustamante, she gets a lot of the credit for this, but I'm going to talk about it. So she wanted to try to work on this traditional kind of Jiko style, or Sigiri in Uganda style cook stove that we see often made. So if you're not familiar with that style, this is what it looks like. Generally, there's a clay liner, a metal cladding, And sometimes there's some layer of what could be an insulation or just some filler material in between those. And there's a little door in the front to allow air to enter up through. Charcoal's loaded in the clay liner and it's burnt in a batch. So that's how most charcoal stoves work. So you load it, light it, wait for it to get hot, put on your food, cook for 1 to 1.5 hours, maybe a little bit longer, and then replenish charcoal, or oftentimes it seems like most people are done by that point. So I liked what Lauren did. She started out kind of along the lines of what D-Lab likes to do, is going to the users first. So we knew the manufacturer well, got together a few students, and during a trip to Uganda, organized a workshop. We call it, co-design or collaborative design, but really engaging users in the design process. So these are a few snapshots, and this is actually Lauren's part of her agenda schedule for that workshop. So you get a sense. Some of it's fun, actually. Most of it, I think, is fun. It's hands-on. There's some kind of ice breaking and team building, but also just giving people a chance who maybe otherwise don't often have a chance to have a voice in the design process. So if you want to learn more about, some of these approaches, D-Lab has some good resources, and I'm happy to speak more about that later. We learned about some challenges. Again, most of these come from the users talking about their experience themselves. And a lot of the users actually came with their own ideas for solutions. So we, took those into account, and you saw in the pictures, they actually had a chance to kind of model their ideas too. Sometimes it's easier to communicate through, a simple paper sketch model than it is to get up in front of everyone and talk about your idea. So we try to use a variety of methods to get that feedback. Here are some examples of the challenges. And if you are familiar with charcoal stoves, these are not that new or surprising. But some of the ideas I thought were really interesting, and we kind of picked up on those and took them back to our lab. One of the things that we looked at in particular is we looked at insulation. And I feel like in a lot of charcoal stoves, the traditional or the simpler ones, there is a little bit of a misconception that the stoves are well insulated. And one of the things that we need to try to do is insulate the stove, get a hotter fire. Hotter fires are cleaner. You can actually burn away carbon monoxide if you have enough oxygen and a hot enough fire within the stove. But oftentimes we're finding, that the fires are just not hot enough, and there's a lot of heat loss through the stove itself. That's what gives us these lower thermal efficiencies, what we call it. So clay, if we look at this kind of spectrum of different materials, I put this together just to get a sense, some of the local materials that we use to make stoves, where do they fall and line up against other things that may be available locally as well. So we have, steel and those metals, obviously they are not very good insulators, so they have a high thermal conductivity. But stones and clay and water and soil, those fall into this kind of mid-range. They have a little bit of insulating value, but there's a lot of materials actually that have much better insulating values. And some of them are naturally occurring, and some of them you can find, like I know you can find perlite and vermiculite in Uganda. You just have to look a little bit. Sawdust can be a way to add some insulating value. So we wanted to look in one aspect, we wanted to look at insulation as a means to improve the charcoal stove. So Lauren looked at 3 different concepts. Some of this came from the users, others came from other researchers or experts or manufacturers who thought this could be an interesting thing to try. So one was adding a metal grate to try to improve the durability, but also possibly the air flow. So you have airflow upward and ash flow down. Sometimes with the charcoal grates, the ash plugs up the holes and we don't get good airflow in. And then we see more carbon monoxide come in as a result in the emissions. So metal grate foil insulation was a kind of non-obvious one, but interesting. And that makes use of especially aluminum foil, but even other, there's some steel foils, but the reflective property of that, right? So you can imagine the clay liner heating up and releasing a lot of heat, partly through conduction through the body of the stove. But if you have an air gap, actually a lot of that heat is through radiation. So kind of like the same way you can use a mirror to reflect sunlight, you can use a mirror or foil to reflect radiation back to the liner. This idea actually comes from Aprovecho, and they documented it in their book, Dean Still's book. So I would encourage, if you haven't seen that book, you should look at it, because he's open sourced some very interesting stove designs, one charcoal stove and other wood stoves, natural draft, and draft. And then the last idea we had was, again, using a material we know to be a good insulator, vermiculite, which is a naturally occurring mineral. You do a little bit of processing to kind of pop it like popcorn. So it's a lot of air then. And then it makes a very good insulator. So we tried that. So all of that gap around the metal cladding and the clay liner were filled with vermiculite. And then what we did is we took these into the lab. So we're lucky to have a nice lab facility where we can take a prototype and relatively quickly run through a standard, either water boil test or some other standard test. In this case, we're using water boil tests. So I'll just show you the results. So actually, interestingly, in terms of thermal efficiency, most of the prototypes performed very similar to the original clay grate. That's the blue bar here. So all were up around 30, 35, maybe slightly over that, which is actually already quite good. So there wasn't a lot to improve on there. When we look at emissions, so here's PM 2.5, we actually saw a big improvement in all three prototypes. So we felt very good about that. PM 2.5 emissions factor and rates, improved by almost half or more than half in all cases. So that was exciting. And CO emissions, we made a little bit of progress going from around tier 0, kind of the worst performance, to about tier 1. So this is still an area that definitely needs some work, but some improvements there as well. The last piece that took a lot of work, but I think is important to consider too in redesigning the stove, is to look at what would the cost of that be. So if you looked at that aluminum foil stove, you might say foil is expensive or vermiculite is expensive to procure. So it's a neat idea as a prototype, but how does it actually affect the bottom line of the business? So Lauren gathered, along with Betty and Helen from the manufacturer, they gathered a lot of the cost information, and she came up with a unit cost model. And this is also an open and available model on the DLab website, which we use for different products. So it's a simple model where you kind of input your inputs and the associated costs. You can change the units of those, or if you buy a truckload of vermiculite versus a sack, all that can be changed. And it gives you the breakdown of unit cost at the end. So this is for one stove. And so what we see is, the prototypes maybe do have a slight increase, but that could be justified because of the performance increase. The user, may appreciate those as well. And not a major. If you're familiar with Ugandan shillings, this is not a huge cost increase. Two other just kind of quick cases, and then I'm going to wrap up and let the Rehema speak. We did a project recently with Happy Amos from Nigeria. So I just wanted to quickly share about that. And it's a little bit similar to the co-design project. This one was slightly different in that Happy actually came to MIT, and she stayed with us for a month. That month I didn't really sleep a whole lot because we were pretty much working 24/7, but it was a very productive month. And what we did is we went through very rapid design iterations. And if you've designed stoves or fabricated, it takes a while, especially if you're not that experienced and you can't work with sheet metal well. That's me. Making one stove is actually a lot of work. So we went through several iterations, design, fabricating, testing in the lab, and then also sometimes enjoying and then repeating. One interesting thing we did here is we looked at the clay liner itself and the geometry of the liner. So one of the ideas that I had recently is, and maybe others have had this, it'd be nice to hear about, the actual geometry of the liner can affect the performance. One, I think it will determine how much charcoal the user puts in the stove in the beginning. And usually, in most cases, what I've seen is people burn through a full load of charcoal. In some cases, maybe they'll pour water if it's not briquettes to save charcoal for another use. But it seems like a lot of people let it burn out. And so that affects the overall charcoal consumption and the overall efficiency of the stove. The other thing I think is maybe there are advantages to having narrower but deeper liners versus wider and shallower liners. And I think part of that also depends on the local cooking style. Do most people use big, broad pots or smaller, narrow ones? Or maybe you have both. So you want to make sure that the stove has the fire itself has a good view of the pot, but you don't have it expanding out beyond the pot, especially. And there's some more science behind that, obviously, but in terms of heat transfer, kind of optimizing your liner size and the fire diameter to the pot, I think is important. So we actually went through some iterations with the liner. We also did some testing on different types of insulation. So Happy was interested in looking at ceramic wool, kind of like you would see in the Jiko Koa made by Byrne. So that was one. She actually, for the first time, was able to try out a Jiko Koa and compare it with her Happy stove. So in the end, we came out with 3 prototypes. And so two prototypes, and we tested those against the original design. And we did these tests in a rigorous way. So we did, at least 5 tests per prototype, full kind of water boil tests. So a lot of the design iterations end up being the testing and the analysis, and a lot of tests are failed because there was some measurement that was missed or something happened. So here's just a quick summary of the results from those. So prototypes with more optimized liners and insulations, and we see quite a large jump in thermal efficiency from about 20% up to 35% on average between cold and hot start of the test. And then even with the emissions, we saw a good improvement as well. So this is the emissions performance, efficiency and emissions performance of the final prototype number 2. So we were able to bring the Happy stove up from I think it was pretty much tier 0 or 1 across the board. So fairly low performance up to, at least tier 2 other than CO. So yeah, again, there's more behind these stories. I'm happy to talk more about the specifics of the prototypes if there's folks who want to know about that. The thing that I'm working on right now is something that we call hybrid design. And so we learn about participatory design, understanding user needs, making sure those are accounted for in your prototype, in your product. The thing that I haven't seen used a lot, and even where it is used, I'm not sure how effective it's been or what it's led to, is trying to make use of some of these more advanced engineering and design tools that we have. So we're actually developing a method which takes user needs gathered through interviews, engagements, co-design with users, linking those to performance metrics, and then finally to product features. And we evaluate those in a computational model. So there's an example of that, one of the results from that simulation that we've built for charcoal stoves, actually specifically built for locally manufactured charcoal stoves. And the idea here is you can do experiments and evaluations on a computer nowadays. You can do those pretty fast. So if you have a good model built up that captures the combustion, the heat transfer, the flow of air and exhaust gases and soot out of the stove, you can actually run through a lot of designs very quickly. And so we're hoping that, like the iterative design process we did with Happy, maybe we can do much faster with the help of a computer model. And ultimately, what we want to do is develop some relatively user-friendly design tools based on this model. So kind of reduce this complicated computer model into a smaller set of design tools made for manufacturers. So that's the most recent project. We don't have a lot of results from this yet. We're just still kind of fine-tuning this model and understanding how we gather these user needs in a relatively quick way and generalized way as much as possible, linking those to the things that people care about, but also the things that the health community and the climate community cares about too in the metrics. So I think I'll stop there and thank you all. Looking forward to Rehema's talk now. Thanks so much.
Thanks, Dan. That was great. I can hear everyone's minds turning about the shape and size of their liners and stoves, and also how they're going to swing a month in Boston with you. So I'm sure you'll be getting calls about that one.
Yeah, come on over.
All right. Michael, are you there? Can you share your screen?
Yep, can you see that?
Yes, if you could just put it in presentation mode, that would be great. And Rehema, are you good? Can you hear us?
Yes.
Okay, you're ready to go. Thanks, Rehema.
Yeah, thank you. Thank you, Danny and Priya, for such a good presentation. Also thank you, Sleepy and Michael, for organizing this. I'm going to talk about the work UGASTOVES has been doing for the past years. Uganda Stove Manufacturers Limited is a project mainly focusing in producing stoves which improve lives via sustainable, innovative, and friendly and environmentally friendly economic products. Uganda Stove is a private. Michael, if you can continue, please. Thank you. Uganda Stove Manufacturers Limited is a private company engaged in production and dissemination of various biomass technologies, and these are categorized in two different needs. We have household stoves, and these are for different sizes of the families. We have different sizes based on the need of the families available. We also manufacture institutional stoves, and these are fixed, whereby we put them in a school or a restaurant's kitchen. And of recent, we are more into promoting the portable institutional rocket stove. The reason as why we are promoting this is because you find some of the schools or restaurants don't have permanent premises. So this idea of a portable rocket stove is working much better with us at the moment. We are also producing local ovens, and these use charcoal mainly and firewood. And these are usually used by different users who are into the baking business. And these ovens are designed in different sizes depending on the need of our clients. Uganda Stove Manufacturers Limited is based in the center of Kampala in Makindye, Kayemba Road. And since we are in the middle of the center, we are able to touch base on the major needs of the urban setting. When you look, please, Mike, When you look at the background of UGASTOVE, our main areas of work are mainly production and quality control. Uganda Stove Manufacturers Limited is mainly now focusing in production because we feel that is what we know best, and we are letting other channels related to the stove with other partners, as I'll take you through as the presentation goes. So at the moment, Uganda Stove is concentrating production and quality control. And here we will try to know exactly what are the best materials to be used when it comes to a good stove, like which materials are good for insulation. Like Dan said, yeah, there is a list of insulating materials like mica, vermiculite, but based on the costs of the stove at the end, we consider which type of insulation to be used depending on the type of the product we are using. So basically, for all the material we use, we outsource them, and we are working with different people, experts, so that we control quality of the products we are using. You can find now when we want to source clay, we are working with Uganda Research Institute to test our clay and see that this is the right clay to be used for the ceramic. And we are also trying to source the right materials from right suppliers for the metal iron sheets. Otherwise, if you go for scrapped materials, you'll find you end up not bringing out a good product. Again, we also focus on design and innovation. We have worked with different bodies before to improve our brand. You'll find when you look at the market, the design is the same. UGASTOVE is one of the first company in Uganda to manufacture stoves. But again, you find we have not stopped from there. We go ahead and improve our design. In the past 4 years, we have worked with Design Without Borders to improve our design. And we have different prototypes we have come up with, those ones using charcoal and those ones using firewood, though they are not yet on the market at the moment. Again, our product is attached to carbon finance. We are the first company in East Africa to collaborate in carbon financing, and of course, this has really helped us as UGASTOVE to improve on the production line, to improve in the distribution line. So the carbon financing, it does a lot when it comes to support into cook stoves in a different way. Again, when you go to distribution, like I said, at the moment, UGASTOVE is more into manufacturing of the stoves. Now we are working with different partners. When you come to, I'll majorly focus on the household stoves. When you come to household stoves, we are working with different NGOs. We are trying to partner with different distributors. So at the moment, we have about a list of 10 who can sell the product on our behalf. Because, you know, distribution entails a lot. There is a lot involved into distribution, and we are looking at working with organized bodies who can really recognize and be able to distribute the stove to the end user. Selling a cook stove is not something very simple. it needs you to be organized. It's a broad section. So that's why you see we are working with other people to do the distribution. When it comes to institutional stores, we are also working with distributors. At the moment, we have our main distributor for institutional cook store, that is Moshi. And this is working well because we find as they distribute the institutional cook stores into the schools, they're also distributing household stores to the teachers within the schools. Please, next slide. Like I said, we have a variety of products. As you see, I'm going to focus more on the dual store. We have, like I said, we are trying to promote the portable institutional store. Then we have the portable oven, but again, it can be fixed if someone has a permanent place. We have the dual and we have the charcoal stove in different sizes. But today I'm going to focus on the dual stove. We are proud that we came up with the dual stove, and the dual stove can use multiple fuels. It can use charcoal, it can use firewood, it can use briquette, it can use sawdust. So you find different homes can be able to use this stove, even if you're renting wherever you are. It is a design stove which eliminates little smoke, but again performing better than if you are using the free open fire stove. So at the moment we are trying to do much more research on how we can do more improvement so that this dual stove is promoted more, and because it has a great inside, and this great, like one of my colleagues mentioned, you find challenges have been there for the stoves where there are no spare parts, but this dual stove has a grate, and we are trying to work on how best we can have a durable grate, because our stove, you can use them between 3 to 5 years when it's still in a good condition. Please, next slide. You'll find that in Africa, or in most of the areas, sub-Saharan Africa, biomass is the main source of fuel. You'll see in Uganda over 17 billion rely on wood for cooking, but again, it's not for only cooking. It has other multiple uses. And again, you find 40% of cook stoves, whether they are improved or not, mainly they use charcoal. And again, you see how, however much we are having a lot of improvement in what to use, biomass still the number one tick, which means at the end of it all, the environment is going to be affected, because you cannot get charcoal from anywhere else. The main charcoal you can get is gotten from the forest around us. However much we are trying to come up with other alternatives like briquette, but you find at the end of it all, the main source of fuel, which is charcoal, is used up, and this means we need to work more on how best we can have the improved cook stoves disseminated in the entire Uganda. You'll see, please, The reason as why the demand for the UGASTOVE product is high UGASTOVE has a potential demand due to its long quality assurance. Like I said in the earlier presentation, we are not only doing a product, but we are trying to see that we have a brand which is satisfying the customers. Like I said, we look more into the materials we use, where do we source them, we do quality control of the production from step one to end. So that's why you see a UGASTOVE brand is well known in Uganda and probably in the nearby East African countries. So you also find out that UGASTOVE market is larger than the number of current households with stoves. Like I said, our design has been worked on in a way which fits all the family needs. And here you see that the demand is really high, and based on the condition at the moment, where you see like the forex cut, there is high levels of prices for charcoal, and then that is why the charcoal stove is in demand at the moment. Then the other reason why a UGASTOVE product is in demand is because, like I said, when we were designing our product, we looked at how best a stove would be. We didn't just wake up and design a stove by ourselves. We worked with different bodies, and here we touch base on what the clients need. Like Dan mentioned, when you're designing or when you're coming up with a prototype, it is very important to know what are the cultures, what are the clients, what the clients say, like what would they need when they want to stove. So we have looked into different things while coming up with a stove, whereby it has the right dimensions and different sizes based on different family needs. In Uganda at the moment, we have other stove types, and I may say they are competitors, but in Uganda today we have other stove types. Some of them are locally produced, and some of them are imported. Like Dan mentioned, there is a lot of sensitizing cook stove manufacturing in Uganda at the moment. So as you see on the list, we have the imported ones like EnviroFit, Jikopoa, BioLite, Ban, and then we have a list of other local producers like Green Bio, Energy, Cesar stoves, Four stoves, BM stoves, Eco stoves, and many others which have not been mentioned here. But again, you see the design of the cook stove manufacturers in Uganda is almost the same. But what differentiates the brand is what you put in, as in assurance, quality, which materials you use, and that is what makes UGASTOVE and other people different, other stove manufacturers. Yeah, but yes, we have many cook stove manufacturers in Uganda. And again, you see that sometimes it's a challenge because some of the stoves on the market are kind of substandard, and this really affects the term improved cook stove. Yeah, I'll still go ahead and take you through the product and the 4 Ps.
Just
affecting them.
Rehema, we'll just have to cover this kind of quickly so we leave a little bit of time for Q&A.
Okay, thank you.
Okay, thank you.
Yeah, I'll quickly take you through the market challenges at the moment, whereby we have product price, place and promotion. You will find that a product has to meet the user need. And here UGASTOVE, like I said, has collaborated with different bodies to come up with the right product. Hence, you would see that is why it is a good brand for the market. Again, when it comes to the price, you will see that it's not easy to afford a cook stove, an improved cook stove, and making one payment at a go. So the other alternative solution would be probably subsidizing the product via carbon finance, but this is not sustainable. The other alternative would be working with microfinance to help into that. Then the other challenge is the place for scaling up manufacturing. But again, this can be solved by, again, involving carbon finance to make the industry grow. The other 4th challenge is promotion, and promotion here needs effective marketing. But again, you find that, like I said, UGASTOVE is trying to work with different distributors to try and work on the above challenge. At the moment, please next slide. I'll look at constraints and solutions quickly before I wrap up. At the moment, we are having a challenge of setting up steady warehouse in Uganda. UGASTOVE has tried to come up with a steady warehouse, but again, you find the resources are not available. Though we have gotten grants from different donors to try to improve the production. We are also facing the technical and managerial skills, but again, you see this can be solved by partnering with international experts, and again, continuing with mentoring programs. Yeah, there is also a constraint with political support. We have a body, Uganda Renewable Energy. We had a policy which was set up in 2007 to increase adoption, but you see the uptake is not as it would be at the moment. So the solution would be trying to work with current organizations like UNA, so that we can try to bring in what is affecting us. For example, you see the main sources of materials like iron sheets, the taxes are really high, and we feel that if this has been worked on, it will really help reduce the price of the stove, and it will be promoted in everywhere. Thank you very much, Priya, and thank you everyone for listening to me.
Thanks, Rehema. That was very interesting to hear about your experiences at UGASTOVE. Really appreciate you being on with us here today. we have a couple questions we're just gonna dive right into because we don't have all that much time left. One question for Rehema was from Leo, and it was, let's see, where is that? Oh, have you, and I had a related question, has the thermal efficiency of your dual stove been determined? And I also was curious as to if you use the dual, if the dual stove was being financed using carbon financing, and if so, did you have to rate each fuel use as in terms of tiers for the stove? Rehema, you
Thank
answer
you.
that. Thank you.
Okay, thank you. Yes, our dual stove has been tested, and we have the results. And the finances for coming up with the dual stove have not been mainly from carbon finance. It came out of one of our donors in 2017. I don't know if I got the last one.
So, and is it, have you tested it, where does it fall on the, like the tier ranking that
Tiers,
Dan used?
Yeah, at the moment it is tier 2, but we are trying to see how we can improve it better. Okay. There was a couple questions in the chat, and I had this question as well about the height, and I think this is a question for Dan or Priya about the height of the burner and whether the stove sits whether the pot sits in the stove or above it. And it sounds to me like that's a trade-off between airflow and insulation. Can you add anything to that?
Yeah, that's true. And it, I mean, there are two ways of improving stove efficiencies. One is you improve the heat transfer, and other is you improve the combustion efficiency. Improving the combustion efficiency will also reduce emissions. So that is the approach that is more favored. But there is a lot to be gained by improving heat transfer, and the size of the pot holders does play an important role. And I think somebody also commented that if you have the pot sitting too close, if the pot holders are too small, or it is just sitting flush, then there will be smoke emission, because you do need air to burn the combustible gas that is coming out under the pot. So one has to play around a bit with the pot raisers to figure out what is the right height, which gives you low smoke and as much heat efficiency as possible, heat transfer as possible. That's all part of the designing process. If there are designs where you can sink the pot inside the stove, but there you need to then have some kind of a chimney to create a draft, or you can also have a pot skirt, which will reduce heat being wasted out of the pot itself. So there are various approaches for improving heat transfer efficiency.
Okay, so it's not necessarily a trade-off, it's just a design test. So you can increase airflow and improve the insulation. Okay, good. So I have a question here from Abby. We look to charcoal as a source of most of the cook stoves. The production of charcoal is a huge driver for deforestation in Southern Africa, including in Zimbabwe. Are we solving the carbon emission problem this way? And it sounds like a Priya question, basically addressing the whether or not it even makes sense to be looking to, in a sense, encourage charcoal by improving charcoal stoves.
Well, charcoal doesn't have to be made by cutting down trees. You have a lot of woody biomass that is that is available as agricultural waste. So in the Indian context, for example, we have coconut shells in the area that we work in. If we don't use it as fuel, then it's a nuisance. I mean, it will have to be incinerated or burnt off, and that is going to cause pollution anyway. So if we can find biomass wastes, even dry leaves and dry grasses can be charred. That will give you char powder, which you can convert into char briquettes. So we call these approaches renewable charcoal. It is possible to find renewable sources for making charcoal or char briquettes, and that combined with an efficient charcoal stove, you can then create a carbon neutral, sustainable chain, which will also provide waste management service. So that we have to find those opportunities to shift away from cutting down trees to make charcoal.
Great, thank you. Here's a question. I think this is probably for Dan. Dan, have you worked with non-carbonized briquettes and found a way to reduce some of the smoke that is generated from non-carbonized briquettes? I know that's an issue we're always talking about, whether or not we want to focus on non-carbonized or carbonized briquettes.
Yeah, I guess I'm mainly focused on carbonized fuels, but yeah, a little bit on uncarbonized briquettes. I don't have a lot of experience with, but I mean, in general, similar to a wood fire, trying to reduce emissions, there's a number of ways of doing it. So I actually, I have a couple little tricks I use when I teach about cooking with firewood. Is you have the fire triangle, right? So you need three things to make fire. You need a fuel, you need air, and you need an ignition starter, lighter, right? Some way to make fuel and air won't burn by themselves. You need matches or something like that. To make a clean fire, you can use what we call the 3 T's: time, temperature, and turbulence. Turbulence is the less obvious one, but can you keep the wood gases for a longer time in a higher temperature combustion chamber or environment? And can you mix the air and those wood gases or uncarbonized briquette gases? Can you mix them around a lot so they interact and react and convert to cleaner emissions? So in short, the triangle and the T's.
So sounds like we have a whole new webinar to schedule on the T's.
I can just add one
Priya.
point to this non-carbonized versus carbonized briquettes. I think we also have to look at the energy input and the kind of machinery, the cost of that, and all of that. To briquette biomass as it is, you really require a very high pressure, and therefore the machinery uses more energy and is also costly. Whereas if you carbonize biomass, then you just need to add a binder, and a little bit of pressure will give you reasonably compact briquettes which can be burned in a decent charcoal stove. So there is that trade-off also at the production of those briquettes level.
Okay, great, thank you. We're pretty much at time, so we have one last question we're going to wrap it up with. If any of you have any experience with, this is from Sahil, how to introduce and track cook stove utilization in migrant laborers in India or anywhere else in developing countries. So like Dan's gadget, is that something that we can use on other stoves? Do you guys have any thoughts on that?
Not really, but one thing is that with migrant or the itinerant laborers who are always on the move, generally the cooking is happening outdoors using whatever fuels that are locally available to them. So that sort of continues to be a 3-stone fire. There have been some attempts to try and give them portable stoves, but again, an improved cook stove also then puts some restrictions on what kind of fuel one can burn there. So it hasn't quite worked out. People will cook with 3 stones and using available fuels, but it is outdoors, so relatively less of a health impact associated with that.
Okay. And Dan, do you have any comments on the portability of your tracking, of your cooking tracking gadget?
Yeah, I'm not sure what Sahil is thinking about doing there, but yeah, those, you can install these gadgets and let them move around. The challenge would be you have to go and collect the data at some point. So you got to find this person or the stove at least.
Okay, we're not yet at the point where you can, I doubt the itinerant workers are going to have a laptop with them to upload the data. So I guess you would have
Yeah.
to, you would have to. Okay, all
And
right.
if you want to track their location, then yeah, anyway.
Yeah. All right. Well, thank you very much to our speakers today, to Priya, to Dan, to Rehema. We really appreciate your insights on this topic. If you have any other questions, you can get in touch with me directly. I can forward them to to any of our panelists. We, again, as I said, we will be sending out the presentations and the recording within a couple of days of collating everything. And again, thank you all for joining us. It's been a good crowd, and we look forward to having you on our next webinar. Take care.
Thank you. Thank you, everyone.
Thank you.
Thank you very much.